is the famous 1.604 megahertz, and that is reading out from a 1921 Kennedy receiver, model 281. This is the same receiver that is featured in the famous Royal Raymond Rife laboratory photo from 1932 to 1934, which was used in the famous Scripps study, which effectively treated 16 cancer patients. There is your Kennedy model 281 right there. If we were to diagram the way this Kennedy model 281 setup is made, the diagram would look like this. Now here's how to read this diagram. On the left side you have a heterodyne setup. You have two signals, one originating from the Kennedy 110 and the other originating from the Kennedy 281. They add together and create a heterodyne. Now, this receiver on the bottom is oscillating at 1.8 megahertz. And that feeds into its audio amp. The receiver in the middle, the Kennedy 281, is oscillating at 1.604 megahertz, and that is feeding into this system here, which is the signal that is used in the actual Rife machine. At this point here in the diagram, you obtain a signal of 1.604 megahertz carrier that is modulated with a pretty shallow modulation of 196 kilohertz. And we can prove that by, we're going to simulate the first receiver, the Kennedy 110, by just injecting a signal of 1.8 megahertz into the antenna input of the Kennedy 281. Now we have our oscilloscope right here connected to the output of the Kennedy model 281, and the signal looks like the following. It actually reads out to be 1.604 megahertz, that is the carrier, and the signal looks like a modulated carrier, and the internal carrier frequency is 1.604 megahertz, and the modulation bumps, the modulation signal is exactly 196 kilohertz. So it is believed that this is the Royal Raymond Rife BX mortal oscillatory rate frequency